Let's go ahead and show that 1 plus sine x over 1 minus sine x is tan x plus secant x squared. Now, when I look at this problem, I see a couple things. On the left-hand side, I see an opportunity to multiply by 1 plus sine x over 1 plus sine x, because that would change my denominator into a cosine. But I also see on the right-hand side where I could go ahead and start foiling. Tan x plus secant x squared. I can go ahead and FOIL that. So I think I'll go ahead and try foiling tan x plus secant x. So let's see. So the right-hand side. By the way, I don't know, if this is going to. I don't know if this is going to work. I don't know if this is the best way. Just trying to communicate what's going on in my head so you get a sense of how to approach these problems. So this would be obviously tan x plus secant x times tan x plus secant x. And so that would be tangent squared x plus 2 tan x secant x plus secant squared x. And I suppose at this point I can go ahead and get a common denominator. So this was FOIL. That would be, or not a common denominator, but I can go ahead and rewrite tan and secant in terms of sine and cosine. So that would be sine squared x over cosine squared x plus 2 tan x, so sine x over cosine x times 1 over cosine x plus 1 over cosine squared x. So this is reciprocal. And I see that everything has cosine squared x. I don't even have to get a common denominator. And so this would end up being sine squared x plus 2 sine x plus 1, all divided by cosine squared x. So this is just fraction addition. And now, what am I going to do with this? I think I can go ahead and apply some algebra skills here. So I see sine squared x plus 2 sine x plus 1 in the numerator. Now, what if you had seen w squared plus 2w plus 1 in the numerator? Well, you could go ahead and factor this, right? This would be actually just be w plus 1 squared. Well, so if you replace all the w's with sine x, that's exactly what you have in the numerator. And so what we have is, I guess, sine x plus 1 squared divided by cosine squared x. So this is just factoring. I think this step is probably the most difficult to see what to do. Everything else has been things that we have seen before, but this problem has this little wrinkle where you need to factor a polynomial with trigonometric functions here. So again, the way that we do that is we use our, or the way that I like to think about it at least, is I think of w as sine x. So if w was equal to sine x, then what you have in the numerator is w squared plus 2w plus 1, and that factors as w plus 1 squared. All right, so now what can I do with this? Well, I look at this and I'm not sure, so I guess I'm going to go back and try to see where I'm trying to get to. So I'm trying to make the right-hand side look like 1 plus sine x over 1 minus sine x. Okay, well, I'm encouraged by the numerator because that's 1 plus sine x, right? But this denominator is cosine squared x. But I can, and that's discouraging because I want something that looks like sine x in the denominator. But I can easily introduce sine x into the denominator by writing this as, by using the Pythagorean identity. So this is 1 minus sine squared x. So this is Pythagorean. And now all that's left to do is I see in the denominator I have a difference of squares. 1 minus sine squared is a difference of squares, and you can factor difference of squares as a plus b, a minus b. So in this case, a is equal to 1 and b is equal to sine x. And so the denominator is going to factor as a plus b, so 1 plus sine x times 1 minus sine x. And now we have a 1 plus sine x squared in the numerator. One of those will cancel with my 1 plus sine x in the denominator, and I get 1 plus sine x divided by 1 minus sine x, which is the right-hand side. I think it might be worth it to go ahead and try that other way, starting with the left-hand side and seeing if that works. So left-hand side is 1 plus sine x over 1 minus sine x, and what I mentioned is you can go ahead and multiply this by 1 plus sine x over 1 plus sine x, and what you get is 1 plus sine x squared over 1 minus sine squared x. Okay, so this is multiplying by something special. That's what we called it. And now 1 minus sine squared x, that's cosine squared x. So I have 1 plus sine x squared over cosine squared x. And now finally I can write, if you have one thing squared over another thing squared, you can write that as 1 plus sine x over cosine x all squared. And my motivation for doing that is if I look at the other side here, tan x plus secant x squared, I have something added together all squared. So maybe I can get something added together squared if I combined these squares here. So let's go ahead and say what we're doing. We have done the Pythagorean identity, and now this is just an algebra step. And now I can go ahead and I have a fraction here. I can split up that fraction as 1 over cosine x plus sine x over cosine x all squared. And what is this? This is nothing more than secant x plus tangent x squared. That is the right-hand side. So a couple different ways to go about this problem. I wouldn't say that one is more correct than the other. They're just two different, you're taking two different routes.